you're trying to decide if a cosine wave, is it going to be that one or is it going to be this one? In other words, is the cosine wave going to start up here and dip down and come back up? Or is the cosine wave going to start right here, go up and come down through and then back up? Left or right is going to be your vote when it comes. Please vote. Which one of these two do you think is the cosine wave? One is this left one here. Two is the right. Just show fingers, that way I can kind of see everybody all at once. Okay. One more vote. Yeah, it is one. Cosine starts at the top and dips down to the bottom. It's almost a good idea. This is my first time doing it that they've done this, where they're reviewing their stuff, which I kind of like. You don't have to learn something new, but you do have to remind us something that you know. You can actually unstaple those. I just stapled the last one so that they'll be together. So left one is cosine. That is this guy right here. This guy over here is what? Anyone know the name of this guy over here? Sine. He is sine. We're going to focus more on cosine in part because they're going to kind of maybe use that one more than the other in this final stage. What do I need them to know? Get a highlighter. There's two things that I kind of want you to highlight. One, obviously, I want you to highlight the word sine, that way, cosine, that way it jumps out at you when you're on this piece. The other thing that I want you to do, let me put that away for right now, so that's left. The other thing I want you to do is to highlight the equation. Now, this equation actually is going to turn out to be pretty important this time through. So let's remind you about it and see what you remember. The easiest one to remember is the k. What will the k do to the graph when we have it? Will it move it up, down, left, right, or flip it? Up, down, left, right, or flip it? What will the letter k do?
Right.
Left, right is close?
Up, down.
Yeah, up, down. The last number at the very end will tell you to go up or down. Usually it's a 0, and so they don't write it. So when we do ours for the performance task, part of what they're going to want you to do, we're going to build ours. They're going to give you one built, and then you'll have to decide, okay, first, is it sine or cosine? Second, did they move it up or down from the original position? And if so, what number do I put in the place of k? The A, anybody remember what the A tells you? It's a long time ago.
If it's going to be negative or positive.
It does tell you that, but then that A also stands for a word. Amplitude. And amplitude, what is amplitude if you remember? Both of these have amplitude if they were a roller coaster. What is that? That's from the old school and the parabola. In this case, it will be the sine, cosine, so it's something else with it too. Amplitude,
It's from the tips or the top, how close it is to the bottom.
Yeah. So when you think of amplitude, you're thinking of the height of that thing. That is, ground level, you're on a roller coaster. I'm using the sine one because on the board, it looks like a roller coaster, so it can relate to real life. But the amplitude is like, if I was standing on the ground, I was looking at that thing like, oh, shoot, that thing goes way high. Like, oh, shoot, I'm getting on. You're looking at the amplitude of a roller coaster. Now, what's also true is the amplitude goes all the way down to the bottom, too. The same distance it goes up, the amplitude is the same distance it goes down. One way to find the amplitude, sometimes if the numbers are weird, you can just add the bottom number. You can do the top number minus the bottom and cut that in half. But for now, we'll just figure it out looking at it. Again, when you're given it, it'll be a roller coaster built. So what you'll do is you'll check the roller coaster, like, well, from the ground, how far up does it go? Oh, okay, that's about 100 feet. The amplitude is 100. Or on this one here, this weird roller coaster that starts up high, and they just drop you and you come back up. Again, from the ground floor all the way up, you'll be like, oh, okay, that's about 100. So finding the amplitude, easy. The K, that one's going to be a little bit tricky. The K is this line that cuts the roller coaster in half. For the purpose of what you'll be doing today, know that half of the roller coaster needs to be above ground and half of it has to be below ground. In other words, if they give you a picture and they haven't sliced it yet, your job is to look at the picture and see, like, where could I slice this picture where half of it is above the line that I wrote and half of it is below the line, and that's going to be your line K. The H we're not going to use as much, but the H is what moves things left and right. Sometimes on some of them we'll look at, for example, we'll look at the harder version, but today I think your version might be the easier version. All right, so let's do this. Let's build a couple of them. Eventually, write down our formula: y equals a, x minus h. Yeah. Oh, that's why it's that. Yeah, you're right, Tesla. This thing is for the parabola, the way they have it written. Actually, let's go ahead and write this. Y equals, a is still there, but this x part is going to be cosine. For our purposes, I'm just going to make it cosine x. And then plus k. Now, part of what I'm doing there is simplifying it so that we don't get completely confused, but I'm willing to do it this time. If someone, I think if some of my colleagues were here, some of my other math teachers were like, no, you need the whole thing, the real thing, all of it. But again, for what I want to be able to do, I'll go with that. All right. So on to page 2, compliments of my colleague Richard Aguilar. He's now an assistant principal. He's a math teacher. He just got promotion to be assistant principal. He helped create these. All right, y equals cosine x. Hey, what's that? All right, a long time ago, a long time ago, that was Corey. It's coming back. Step 1, we need to mark the regular amplitude for a cosine wave. Normally it's 1 and 1. Now here's a trick. You could make this first little box to be your 1, but then it's so hard to see. So what I'm going to do is this. I'm going to take a chance on mine by making, I'm going to make it every 3, every 2. Sure, I'll go every 2. So on my thing, this might be a bad choice. How small is it on there? So I'm going to put my 1, 2, -1, -2. Now, in a better world, these boxes would be bigger, and so each box would just be 1 and 2 and so on, just like that. Does anyone remember how we split it up to go from left to right? How many marks did we make to go to the left to right? And that's kind of the point of doing this new version. So like, hey, Unit 10, let's just do something brand new. I bet they remember what they did in Unit 6. Like, no, we don't remember. And if we have to build it again, we wouldn't be able to. And so again, so Tessa, you see, like, in any case, let me just build this one, and then we'll have you kind of build something else. So I use all the time rebuilding. Step 1. I'm going to do it small. Basically, you need 4 blocks. I feel like I must have skipped some. I feel like it's going to be extra tight. I'm going to do it extra tight. It just feels weird, like every 2. All right, so there we go. The line across here is money. Money is the way I want you to remember it. You need to make it up to $1. Up to $1. How do you do that? Every 2 of these, you're going to put a dot. So there's 25 cents. The second one, there's 50 cents. Third one, that's 75 cents. And the last one is $1. 4 dots there. 50 cents is very important because that's halfway to your dollar. So that one gets a special dot. And your dollar gets a special dot. Now again, technically this thing won't be money, but just so that your brains are easier to remember it. Now here's the deal. In terms of money, 25 cents is such a little bit amount of money that something's going to happen at 25 cents, and something's going to, so let me put some marks here. At 25 cents, something special is going to happen. Below the 50 cents, something special is going to happen. And right through 75 cents, something special is going to happen. So notice that little pattern there. 25, 50, and 75. Something special happens to them. For cosine, here's how it goes. I'm on a roller coaster. They pull you up into the air. I'm not sure what kind, like Superman. It doesn't go all the way down here, but the idea is you are going to start up high, and when you start going down, you go through 25 cents, and what you bottom out at 50 cents. And you come back through 75 cents, and then the ride ends up high where it started. That's the cosine wave. Start high, go low, and high. Let's put in some of the real numbers from a long time ago for what the 25 cents, 75 cents is. This one here is pi, the middle halfway. Anybody know what the last one is going to be if the middle is pi? 2 pi. And then, of course, the in-betweeners are tricky. Halfway from 0 to pi, anybody know what that might be? What's halfway between 0 and pi? It's literally pi divided by 2. Half of pi is what that is. And then his friend over here, halfway between pi and 2 pi. Do I remember what we used for that one? Yeah. So that one actually is going to be, maybe I can put it down here, 3 pi, or 3 halves of a pi. I'd say each one of the dots is half of a pi. So you have half of a pi, put 2 halves together to get like a whole pi. Then you add another half of a pi, that's 3 of them, and then 4 pi, I don't know how to say it. In any case, there's the picture and how it begins. What's most important about this one is how we write this equation. Let me see if I can write this equation on the full one for this one here, write the one below it. Please write down this general form of the equation. I want to write so many times that if someone said, hey, write the general form of the cosine wave, you'd write y equals a cosine of x plus k. That's the full deal right there. Now write it small because we're going to put the actual equation for this original below it. We'll move a few of them around and then try to see if we can build up on some other stuff. All right, so here it comes. In this one, how high does this roller coaster go from the ground floor? Let me put the ground floor, see if I can put the ground floor in red. So they can see that the ground floor is red. Okay. From the ground floor, how high does the roller coaster go? 2 is close. I know why you would say that. I see 2 up here. Yeah. It actually only goes up to 1. I only put the 2 in there to show you that every 2 blocks is 1, 2, 3, and so on.
And we had to do it the same way right here, right?
Say it again?
We had to do the same way right here too, like skip 1.
If you didn't, it doesn't hurt you that much. I just did it so there could be enough space. Let's say you put 1 here and 2 on the next one. That's technically okay, as long as your scale is all right for all of those. In other words, as long as you count every block to be 1. I count every 2 blocks to be 1. In any case, my A, the amplitude that Oswald just said, is a 1. So you put the 1 in the place of A. I'm going to tell you why normally they don't put a 1 there, but I just want you to be able to build it just in case the amplitude happens to be a 2, you know where to put it, or a 3, you know where to put it, or even a 3.5, 4.2, you know where to put it. Next thing in mind, you got your cosine. This one we're just going to keep it as x. Nothing happened, it didn't shift right, it didn't shift left. Trick question, let's see what they say. Okay. In this case, the red line is at a certain number on the y line. There's 1, there's a 2, there's a -1, there's a -2. Where is the k, that red line?
0.
Yeah, it says 0. We never write 0. But what's true is if you're counting on the y line, you try to figure out where is the k, the vertical shift, in this case, is at 0. Now here's what's true. If you wrote down that equation, this would be the equation of that cosine line. If you were on a test, on a multiple choice test, and they showed you on a standardized test, here's how they would write it. 1 times anything is just that thing itself. It doesn't change. So they never write 1 in front of a variable, so they just write y equals cosine x plus 0. If you add 0 to anything, that thing stays the same. And for that reason, they would never write a plus 0. I'm going to ask you to do it to show me that you recognize why there's no 1 and why there's no 0. But I need to be able to tell it. Do they know that line here, the vertical shift they call it? Where is it? And do they know how high the roller coaster goes? So, no big deal. All right, so let's see then. I'll do this one together, and then we'll have you do this one on your own. So we'll do this one together in case you watch the video. This one I'll have you do on your own. So here's the deal. The move it up 2 units means take the red line and go blink, blink. You move it up twice. Once you go blink, blink, and you move it up twice, then essentially the same picture you just made here, you're doing it up here. It's going to be a little bit weird. Let's see if we can piece this one together so you can be reminded of it. Okay, I remember what we did here. Again, for the task, they're actually going to have the picture already formed for you. And it's going to be your task to break it out backwards. Like, okay, where's the red line? What's the amplitude? And that'll be it. So basically, it's 2 things you're trying to find. So let's see if I can put this in here. If I did 1, oops. So if I were building this one again, it looked like this. I took my 0, my 1, and my 2. In this case, I'm actually going to need a 3 for a reason. You'll see why in a moment. I can put my -1 and my -2. So the very first thing they want me to do is, instead of this black line being here, they want me to move it up to blank blank. So what I'm actually going to do is I'm going to draw the new arrow. See that before we had that black arrow, and we're using that. They didn't say the amplitude changed or anything like that. They just said we moved it up. And let me also do this, just for this one. Let me also say, and you can put into, that it also has an amplitude of 2. It's moved up 2, and just like I wrote on the board, it has an amplitude of 2. Write that down. And so what we're going to do with that one there is, I'm going to actually need a 4 up here, and they'll see why in a moment. All right, so first thing, put in your money. 25 cents, 50 cents, 75, $1. So here it comes. Every 2, so you are 25, you're 50, you're 75, and you're $1. Okay. For cosine, because the amplitude is 2, let me ask, am I going to put my the height here at the very beginning, that black dot, am I putting it next to a 3 or next to a 4?
3.
3 is going to be close.
4.
Yeah. 4 is actually going to be it. The question is, well, why wouldn't 3 be it? From the red line, I know it looks like 2 blocks, but you know that. I know like maybe what you're thinking. To go from 2 to 3, that's 1. And from 3 to 4, that's another one. So I'm actually putting it up here. That's how high that roller coaster is going. From this new ground level, they take you up to the new ground level. They're like, all right, now from up here in the sky, we're going to make this thing go up like boom, 2 amplitudes higher. And now we're able to start putting in our things. Over here, the middle only went 1 below, but because of the amplitude, we got to go bang, bang, we have to go 2 below. Let's see if I can show that. First, let me put in my whole thing, my pi. Oops, not there. That's pi over 2. My pi over 2, my pi. My 3 has pi, and then my 2 pi. Okay, remember those famous numbers. 2 pi is the distance all the way around a circle whose radius is 1. Below pi, the middle guy, he's an important guy. I don't go down just to 1. I have to go all the way down to 2. Hopefully they can see that. Why do you gotta go to 2? Well, on the top floor we went 2 above the ground level. Bottom floor we have to go 2 below the ground level. All right, and at this point, see if you can use this over there. I'm going to pause and let you try and draw it. I'll put in one other point for you. So you can draw it. I'm going to come around and put a check mark with whatever you draw. Just draw in pencil. All right, having checked around, it's true. It starts up here, cosine. You hit 25 cents. Down all the way down 2 below. and then up through 75 cents. That's what you all the way up. All right. The last one we're going to do before we start looking at some of the other ways it's going to look is everyone try to do this one on their own. Bottom row far left, bottom row far left. Keep the amplitude at 1. Oh, we didn't write down the formula. Let's write down the formula. Do me a favor, try to write down the formula. In other words, write down, again, so that the more you write it down, the less you have to memorize it. Write down the general form of it, and then put in what your K would be. In other words, what's the ground floor, or the red line. And then put in what your amplitude would be, in this case given, but if we have to look at a picture, that's what I might need to do. Look at a picture. Let's see. No, we'll do these easy ones, then we'll back up on ground floor. Alright, I'm recording right now. I'm just writing the formula, then we'll see. They didn't give you much space there, did they? So I guess that y equals a cosine x. I know it's supposed to be cosine x minus h, but I'm going to keep it simple. I really probably should have that cosine minus x, not x minus h, just in case it ever moves left or right. All right, here we go. Let's see. There are only 3 of us, so one of us may not get the answer. But someone say what I'm going to put in the place of the a. What's the amplitude? 2. All right, 2. Got my cosine x. Someone different. What is my k going to be? 2. Yeah. And as a teacher, I probably shouldn't have used. As a teacher, I probably shouldn't have used the same 2's. So let me make the second 2 the actual amount that it was moved up. And so that's it. No big deal there. So do this. This last one, you're going to try and create the whole thing on your own. We're going to keep the amplitude as it is. They didn't say there's a new amplitude. But on the bottom row, do that one. After that, we'll try one of the problems that look a little bit more like where we're trying to get to.
Would it be negative too, or is this going down?
Well, I won't say anything. What I'll say is put your numbers on your thing, try and draw your picture where it goes, and once you have a picture, then look at your picture and try and decide what my new red line is, and that might tell you the answer that you're even asking the question. I'm going to erase here, and what I just said is, in a problem, if they don't tell you what the amplitude is that you have to draw, automatically the amplitude will be 1. And so, yeah, when you draw yours, it'll change. I'm still going to check mark it to show that the steps are there. And then if you can also write in, they're going to give us the line swinging, like the green line here. We're going to have to first cut it in half, so that the same amount above as there is below. Once we cut it in half, we now have our K. We know what that is. Then, from where we cut it, we're going to try and count up to where it goes up to. How much does it go up? So that's 1, 2. Let's see, 1, 2. Okay. Then we know that our amplitude is a 2. That's what we're going to do in the next version of it. But let me see if I can. I wonder if I drew this picture, if it's going to mess up what's there. But I'm going to move it anyway and try and draw that picture. And then we'll give you a second handout. And we'll also try and create the formula for this one. Well, it's definitely kind of a bad day to miss. Granted, it's being put up on the board, but being here and watching the video are 2 different things. In any case, let's see if we can split this thing up. Step 1, they want us to go down 2, so we got our. I saw -1, -2. I'm going to put a -3 and a -4 just in case I need them. The new ground floor for this roller coaster is right here at -2, which is going to help answer your question about who's K. Next one, we do our money, at least that's the way I do it. 25, 50, 75, $1. We got a pi over 2. We got pi. We got 3 pi over 2. And then we got 2 pi. We know here we go up just 1 floor. For the amplitude, so just go up 1. And over the pi, it says just go down 1. And of course, the roller coaster ends off at the same level it started. And so, I'm going to go through go through 25 cents, down to the lowest amplitude, back up through 75 cents, and to that. And it's important to put the key dots in there. And that way you have it. All right, let's see. Do me a favor, please. Please write down the general form of the equation. Why do you have to keep writing? The idea is some things you memorize, you look at it and try to memorize it. But things that you write a bunch of times, you don't have to try to memorize it. It's like writing a phone number or something like that several times. Cosine x plus k. All right. I guess I'll ask it. Someone say what the amplitude is in this one.
Is it 1 or -1?
It is actually just the 1, and that's a good question. Why is it 1 and not -1? The amplitude asks you how much higher than the baseline, than the ground floor could you go. So I started at -2 and I climbed up just 1 to get up to a -1, but I still only went up once, 1 unit, 1 space, 1 amount. And when I go down below, I go down just 1. So it's almost like asking a height. So I say, hey, about how tall are you? I mean, I don't know, about -5 feet, 6 inches, something like that. Negative what? Negative. Yeah, your height can't be negative. So the same thing with amplitude. Amplitude is a height. So even if you want to say, I think it's -1, part of you has to go like, it can't be -1 feet tall. So it's like that. All right, someone different. What is the K going to be?
2.
Is it positive or negative? All right. Now this one, it does depend on where it lands. So on this one, because the red line, new red line is at -2, you actually have to say, well, where's the line? Like, where is it on the Y? That's at -2. All right.
Okay.
Yeah.
Okay. -K.
Yeah, keep doing that. Keep doing that. All right. One of me says a -2. But that's cool that that's important to be able to see it and go like. Anytime you can correct someone, that means you know what's going on. What would not be here on a standardized test in that formula? That's something they would not write.
1.
Yeah. Now I'm putting the 1 so that you can see it. I want you to put the 1 originally so you can see it. But if they wrote this out on a multiple choice test, a standardized test, or like a real deal, they would write just y equals the cosine x minus the 2. But I need you to know, oh shoot, if there's nothing here, then oh, the amplitude has to be 1. And that's like the original problem up there. All right. Any questions about the 3 that we've done, or the 2 that are still left on the board? That's weird. That one seems to fit exactly, even though it's oh, okay. I get why. But it's because we when we did the one below, I don't know. That's amazing. That's cool. I'm impressed by me. That's weird. All right, whatever. That's where they go. All right. Find out what the amplitude and vertical shift are on.
It's supposed to be a sine wave, right?
Oh shoot, is that produced? Oh. What should I say to them? To make it a cosine wave, go to the top of the hill. That way, where if you were starting at the ride, you chop off part of the ride, and you go to the part where at the top of it, you're at the beginning of that wave. It'll mess up the cosine x part. We'll fix that in a moment, but you can still get the amplitude and the k by just like, oh, you know what? Whether it's sine or cosine, the amplitude and k would be the same. But for now, what is he trying to say to them? Put a mark on that picture where the, if it were a sine wave, where it would actually begin. Like you got a bunch of dots there. He's right, it does kind of look like a cosine wave if you start at the very beginning. But I want you to get on that roller coaster and go to the top of the first hill. And if you had a highlighter or a pencil, let's do it with a pencil, that way if we need to erase, we can. I want you just to draw in connected dots for where the cosine wave is. In other words, just like the things we were drawing, if you were drawing where the cosine wave begins and where it ends, with your pencil by connecting some of the dots. Some dots won't be connected. Try and connect them. Once you do, I'm going to come and take a look and see what you did. If you want to be, where you put in A equals something and the K equals something, and then put in the formula where you're going to write your formula and where you're going to write yours. Part of your formula could be off because there's a piece that I'm not going to include in here because I think because we're going to have access to is going to start at the beginning rather than shifting it over. I'll ask you guys the horizontal shift, what that should be for this particular one. But again, A and K, I had a highlighter. I would ask you to highlight the line that they gave you, trying to figure out what they said is in I'm gonna come around check mark in a second. For it's gonna be an estimate, you know. So how much you think the amplitude is? It's gonna be hard to know the exact number. But if you're in the neighborhood, then I know you're looking at the right thing. And I'll check out David while he's doing one. Figure it out. When you try to figure it out, you really imagine yourself getting ready to get on a roller coaster. And you're walking on the ground. And then when you try to figure out how tall that roller coaster is, you can look up high and see, like, wow, how high does that thing go up? And so that's what you're trying to figure out. And that'll help you get your A. The amplitude. Both of yours, and I saw his. Someone say about what the K might be.
43.
Yeah, 43 is a good number. If you put 42, I guess even I would take a 41. Anything else slightly above 40, definitely not 45. I think David may have chosen 43. Are you okay with why that's 42, Marcos?
Yeah.
Yeah.
It's a little bit of 40.
Yeah. And again, this line, they were nice enough to give it to us. The next one we're going to do, we're going to actually have to try and look at it and decide where the line's going to be to make it that. All right. Mark, I'll give you a look before I do Oswaldo. If you had to guess the amplitude, what would you guess? In other words, now you're under the ride and you're looking all the way up to see how tall this thing goes.
24 maybe?
He goes 24. All right. Be into it, but yeah, the way you kind of look at it is, for me, this is how high the ride goes. I'm gonna make it about 77. Mine might be off from yours. This is where I started. I'm looking up from here at what, 40? We decided 42. And so basically, I just have to subtract, like, how far to go from 42 up to 77.
Isn't it supposed to be 67?
Because it's 7.
Oh, my bad. Yeah. Right. It is 67. Because this is 70, I went above it. All right, so 67. And basically, I just have to subtract those two numbers to know. Because somebody would say, well, oh, your A is 67. And we're like, well, no. If we would have started at 0, yeah, that's true. It would have gone up to 67. But we didn't start at 0. We started at 42, or I think you may have chosen 43. You chose 43. 42. Okay. So I actually have to subtract to find out from. And the way you can think of it too, if I start at 40, it would go up to 27. But I started at 42, so actually going to be 25. But you can see the 67 minus the 25 gives us a 40. What, 42? Oh, what are the chances? I almost wanted to. Oh, no, I did it wrong. You did.
You did it right.
No, I'm actually supposed to do, I put the wrong numbers in the sense that it's supposed to be 67 minus the 42, where I started, and where I ended. Keep putting that 25. 42. Gives me a 5 and a 2. So my amplitude is 25. If you didn't do it, please write down the general form of the equation. In other words, y equals a cosine x plus k. This one again, we decided our amplitude is going to be that 25, cosine x. And then we said that the K was at 42. And this one, it winds up, we don't have to make anything disappear. All right, take a look at that one, see if you want to ask anything about it. We are about to do one extra thing on there. Yeah, I'll try one extra thing. Here, this is the real deal. So we got that part. So it's still available for questions where you get to 25, where you get to 42. Technically, this thing was shifted. For us to use cosine, it was shifted to the right here above the 8. What can we write in this equation to say that this thing was actually shifted to the right 8? The h, so something's going to be in parentheses with the x. Let's see what might be in that parenthesis with the x. Let me keep everything else green so that we see only one thing move. Now, for our purposes, this is enough, because I don't think they're going to shift yours. But just so you will have heard it, and then we'll get another picture to try and do this with. 25, cosine, parenthesis, x, and an 8. What are we going to put between that 8 and the x? A plus or a minus? It's a long time ago. The hint is that it's going to be the opposite.
Are you sure it's an 8?
That was a 7.
It looks like a 6 or a 7.
Okay, I can go with that. So since both kind of mentioned 7, I'll go 7. Between that x and 7, plus or minus. The hint is going to be, is always the opposite. Yeah. So in this case, you think you're going to positive 7, but you wind up having to move it in the it has to be the opposite side because of the formula. Formula is x minus 7. Let me put a star next to what I want you to know. This extra piece was just so that you will have heard it if you see it on a test, like, whoa, where did they get this x minus 7? Well, because it was shifted to the right. And they actually even have some pi stuff on there, which, again, for my purposes, we're going to shift to the second problem for those who are watching the video. You're going to do the same thing to the second problem that you did to the first, which was 1. They gave you the vertical shift, this K line, this K arrow here. But on the second one, you're going to have to choose the K. We determined the amplitude, this red arrow from the ground floor to the top of the roller coaster. But in this second case, you're going to have to determine the amplitude. Well, you're doing the same thing. There's no shift in the second one, so no special cases with negative 7s or anything like that. Even though all of this that we just did just responds to essentially the first question that you'll be asked. Just remembering how to build it, how to find the different pieces. The second question might be a little tricky, and I want to get it in before you go away for a whole week and forget everything altogether. All right. Look, I'm going to come around and put a check mark next to your A and your K, even without, well, I'll put your K and your A rather. Choose the K first, and then choose the A second. Well, I guess you have to choose the K first. You can't choose an A, so you know what the ground floor is to be able to tell. I saw the K's, so I'm willing to put that in here. Most people, I think, went here, which is reasonable. You're on the ground floor now. Of course, you can look up to see how tall that thing is to get your amplitude. Of course, wouldn't the amplitude be different here? So I'm not sure what the real life people would do. If I put in an approximation, I'll go with that higher one.
Subtract the difference.
Oh, I guess you could do that for your formula. You know, almost feel like your formula then would hit anything. Wouldn't really tell you how it goes or how high it really goes.
But like, I'm pretty sure, like, if you were to subtract the amplitude of this one and the amplitude of that one and get the difference, it'll meet at some point in the middle.
I would agree with you. I would agree with you. All right. I'm gonna write. Now the trick on this one is it could be a subtraction problem. Here's what I would do, and then if you're in the neighborhood, I'm with that. I would take this 4.2-ish as the max height. This 2.5-ish. I would subtract those. So that I don't have to do 2 minus 5, which I guess isn't really a big deal. If I wanted to, I could take the amplitude go down. So I could do 2.5 minus this 0.5, which is odd because they won't come out to the same thing. So let me try this. Let's see what it comes out to on this one down here. It comes out to 2.0. But up here, it's going to be something with a 7 in it. 1.7. It's going to be a 1.7. All right. The question is, which one should we take? Kind of because we've been operating with going up as the amplitude. I got a 1.7. Anybody else get a different number than 1.7? That way, I don't know what you think of. 2.2.
My K was different.
You did 23?
Yeah.
Okay. All right. And again, anything that's going to be in that range, and even on the answer, you could say, oh, the range is whatever. All right, so formula, if they were writing it down, y equals a cosine x plus the k. So once we know what our a and k are, I'll go with the 1.7 just because it's on the board, but there's a 2.2 that's out there that's reasonable. And even this 2.0 going down below, 2.5, and I think David may have done 2.3, which is reasonable. And the reason it's reasonable is because we're trying to model a real life situation. And when you model, which is what it's called, writing an equation to reflect something that happened in real life. And when you model a real life situation, it's going to be slightly off. But what they're trying to do is put you in the neighborhood where at least there's something to use for that. Right, Paul, let's take a look. I'm going to say, if we're going to make it sine, the 1.7 and the 2.5, they would stay the same. The only difference is you would have to tell this thing to shift over and start down here and go up. In other words, it would be an x minus like a, looks like about a 6. And that's kind of what you would get there. All right. Back up to this picture for just a second so I can ask the domain and the range. And then we'll look at that real life one there. The domain and range. We're going to look at the domain, and then we're going to put in the range. So at least you know what they're asking you. The range is the easier of the two. So let's talk about the range. The range is kind of connects to the amplitude. What's the tallest number? Well, usually you start from 12. What's the smallest number? And literally the smallest number. How low does it go? And then how high does it go? That's the range. And so the way we write that, put the little square boxes say, on this picture, what's the lowest on this one? Does it look like about a 23-ish, 24-ish? 25. Right. Well, you know what? I'm nervous about the 25.
22.
Yeah, I feel like it's not quite halfway. But let's imagine you put the 25, I'd probably work with you. Because again, it's not like, 13. So it's not like he's out of the neighborhood, it's just how close it is. So I'll put a 23 as well. So how about the highest? And again, I recognize this, it's hard to see.
67.
Oh, right, we did that before when we were trying to find the amplitude. So that's actually a good thing. The amplitude can tell us what the highest number is. So there's the range. The question they're going to ask you is, well, what is that like in real life? Like, what are these side numbers? In other words, what is 23 the lowest of? And what is 67 the highest of? Do they tell us? I know this is for 2 years, I know the bottom thing is in months, so all that 2, 4, 6, 8, those are months when we talk about the range. But what, create a function that approximates, models the temperature in the Canadian city. So the question I'm going to ask you, and we'll give it to you hopefully in 10 minutes, so at least you can start the process. We need to come back to it after the fact. Yeah, that'll be weird, but we will. The range is, what does the range actually mean? The lowest temperature and the highest temperature. Lowest and highest temperature. Lowest temp and highest temp. Temper, all right. Whoa, everything just disappeared. What does that mean? What does that mean? Can I undo? I can't undo? Lowest temp, highest temp. All right, the domain. The domain technically goes on and on forever. So I'm going to put, but then we're going to, in real life, we're going to talk about what it really is. With these pictures, they really just go on and on forever and ever. The wave just kind of rises and goes and goes. So for the domain, usually you put all real numbers. That's the way you say it goes on and on forever and ever. If you don't want to write out the words all real numbers, there's this weird looking R that has a double leg. That means all real numbers. That means it goes forever and ever. But in real life, you can't back up to any of the negative numbers of negative months or whatever. So what I'm going to have to put is kind of when our wave began and kind of when it ended. So our range in terms of months, on this picture, from what month to what month would our range be? I'm sorry, our domain would be. From what month to what month?
Month 7 to month 19.
Yeah, which is kind of weird because I guess there's no 19th month. I guess if it wrapped around.
Oh, I'm looking at the numbers.
No, you're right though. The way we're writing in, so we're putting in the range. I'm gonna go ahead and put it in 7 to 19. What? Month 7 to month 19. Oh, 7 to 19 would be the range we wrote in numbers. But in real talk, let's say, well, what does that mean? We can say from the first month to, how many months does it take to get up to 19 from 7? 7, 8, oh, we can subtract it. 12 months. So 19, take away 7, that would be 12 months. So if you wrote down these numbers and then asked, well, what does that mean? You would say it's, count how many months it is. It's the number of months, the number of time, the 12 months, or for 7 months, it would be, 6 months, 7 months, you write that. So the point I want to make to you is they are going to ask you a question, hey, what's the domain? What's the range? And then that follow-up question is like, well, what does that even represent? Up and down, temperatures. Like I said, we're writing temperature here. The highest and lowest temperature. And then over there, I might have written something else. So the range, what does it really mean? That one was the 12 months, the number of months. The number of months. Number of months they were looking at the temperature. All right. And I guess you can't do negative months. There are no negative months, so you can never use negative numbers are part of all real numbers. Let's see if we can find it here. Basically, what I want you to note is the domain is always the bottom line, like in this case, the months, and the range is always the y, the up and down. We want to identify in the handout you have, what are the months talking about, or rather, what is the domain talking about in real life, and what is the range? So basically what they want you to do is look at the problem that's being described here. what's on the bottom line, and what's the up and down. What is the domain, the x-axis, that is left or right, and what is the range, the y-line, the up and down. All right. Well, let each one of you get to choose which one you would say. One of you gets to say what the domain is, and one gets to say what the range is. Sure, why not? Marcus, I'm going to ask you for the domain, like what is on the X line, what are they talking about? And then Oswald, I'm going to ask you, what's on the Y line, what are they talking about there? All right, so there we go. What's on the, what's the domain? What are they talking about on the X line, Marcos? All right. And while you look for yours, let me give Oswaldo, that way if we eliminate one, then the other one might become even more obvious. What is yours, Oswaldo? What's the range?
It's the even blood pressure.
Uh-huh. So right here on the side wall, they always have to tell you. So Marcos, what is yours?
9 months.
So again?
The time, 9 months, or
Or yeah, time or months. Uh-huh. So they're going to just tell you in real life what the domain and ranges are. They're going to tell you what this is. So that way, for this picture, where does the range begin? I mean, the domain, where does it begin and where does it end? I'm asking you for your range. There you go. Yours might be a little tricky too, but where does your domain begin, Marcos? And where does your domain end? You have to look at the graph that's above to kind of know where it starts and where it stops. And I'm asking you the same thing as well, where it starts and where it stops.
is it the 110?
That is the range. So you don't
Oh,
that one yours.
yeah.
Yeah. So this is the range,
Okay, so it's
and you get the domain.
so it starts at 1 and it ends at 9.
And again, that's kind of what they want you to feel like when they use these words, domain and range. Can you feel that when they say domain, oh, look at the bottom of the picture, and when they say range, oh, look at the left of the picture, but without saying that they want the math term. So you said again, you said 1?
It starts at 1 and it ends at 9.
1 and 9. Okay, we'll take that as the domain, at least of this picture. Theoretically goes on and on. What's the range on this one? What's
Where it
Waldo?
starts and where it ends.
Mm-hmm.
It starts like right in 115,
I'll take the 115.
and it ends at 160.
Yeah, I'll take the 160. So the domain and range. But in real life, what is the domain asking you about, Marcos?
The time period.
Mm-hmm. Okay.
Do we write these right here on number 1 and number 2? Or
You can if you want to.
yeah.
Oh yeah, I see. They ask slightly different questions for 2
Yeah.
and B, but just so I can have a picture that was similar, I wanted that. What does the range tell us, Oswaldo?
How high the person's blood pressure went at those months.
Which would it be amplitude or?
For this case, this picture doesn't fit one of those, so it wouldn't have an amplitude, but you're looking at the picture I think that they're going to give, which is similar to what we were doing before, that it has something like that. So in this case here, it just shows what her lowest blood pressure was and how it goes up until the highest blood pressure. So what they're trying to say is, hey, yeah, this is the math picture, it's a graph, domain and range, but like what information is it actually telling you? So here's what I'm going to do. So if you look at these graphs, domain normally has something to do with time, whereas the range, oh shoot, this picture, you barely see it. Yeah, the range is some stuff, but again, if you read the left, you read the right, you have it. I can't even see my numbers. Let's do this one together really fast so I can actually hand out the main sheet. I wouldn't want to go this whole time and then all the information you have gets to be forgotten just because we didn't get to it. But here it comes. The range, how low and how high? Is it even good enough for you guys to see the numbers?
140 to 2.15.
2.15. And what's the range giving us? What information is it giving us?
Vertical movements.
Say it again?
Vertical movements or the.
But the real.
Dozen. Dozen.
Okay, right. It's telling us the cost for a dozen eggs. So you know the lowest cost for a dozen eggs, and you know the highest cost, which is weird because one is 140 and the other one is 2.15.
No, one is 0.040 and the other one's 215.
0.40. Okay. The other one's 2.15. Yeah. Okay. The domain. What is the domain?
0 and 100.
0 to 100 for our purposes. And kind of what does that tell us? 0 to 100. What is that? What does that mean? Like,
I mean, how much has gone up since they started? To 100 years.
all right, yeah, I was hoping you said something about time. The bottom row just tells you from 0 from the very beginning to 100 years. It's telling the domain just describes how much time has passed. So if I know at 50 years, I check on the domain on 50. Oh, the price was whatever. If I go to 100, oh, the price was whatever. The domain tells me how much time has passed. All right. So for your final handout, as you work, I'm saying this for the video. Do number 1 and 4. Then you can come back to 2, 3, and 5. And write out the general form of the equation, and then the a and the k below it, like we just did earlier. On 4.